Hi, my name is Kamil, and today I would like to talk to you about working with geospatial data, another geo talk at EuroPython. So geodomain is often underrepresented in typical data engineering workflows, but companies and researchers and other domains are using data about buildings, roads, points of interest in different purposes, but often geospatial data comes in weird formats and is hard to process and often need special tools. So I built two libraries, QuackOSM and OvertureMaestro, to make open geospatial data accessible for someone who isn't advanced in the geospatial domain, in GIS domain. And yeah, if you have ever tried to download OSM data at scale, struggled with a tool called GDAL or just like maps, like me, then this talk is for you. First, some words about me. I have studied computer science and data science. For my work, I am senior data scientist at a company called DataPlace AI, and I'm doing geospatial analysis there. And after work, I'm an open source hobbyist contributor. I started in 2022 with a library called SRI, and then I created a library QuackOSM and OvertureMaestro, and you can find me on LinkedIn and GitHub. So, before I talk about libraries, I want to do a quick introduction to geospatial data. First, geospatial data comes in two flavors, in vector and in raster. Vector data is used for representing precise objects, so locations, roads, boundaries, buildings, water bodies, while raster data is basically pixels, images, and they represent values like temperature, altitude, rainfall, or RGB value from a satellite sensor. And in this talk, I will only focus on the vector data. Next, what are the vector features? There's a body called Open Geospatial Consortium, called OGC, and they defined a standard called simple features, where they defined points, line strings, and polygons to represent geographic features in a database. And there's also a multi-polygon, multi-line string, multi-point, and geometry collection. Next. Why is geodata even matter? Where is it used? So I will show you four examples. First, in research, stuff like mobility simulations, calculating urban accessibility, or calculating spatial embeddings for machine learning purposes. And the last one is like my domain. This is what I studied and made my thesis. On the right, you can see the example model output, a heat map. I will go back to this model at the end of the talk and tell you more about it. Next part is public interest. So, for example, in disaster response mapping, in urban planning, and in humanitarian help. And you can see the example of tracing satellite images into like before and after disaster struck, the typhoon Haiyan in 2013, where contributors, volunteers looked at satellite data and marked objects for government bodies to help them locate where the disaster happened. Next, businesses also use geospatial data in site selection, custom navigation, and in local marketing, for example. And here's the example of the ASDA network, where they used OpenStreetMap data to create site selection tool for finding best location. And the fourth one is in the gaming. You probably heard about the game Pokemon Go. They are using OpenStreetMap data. Here is the screenshot from the City Bus Manager Steam page, where you can run city bus operation on your own, in your own city, and, for example, 911 operator as well. Okay, so there are two main sources of open data, vector data. The first one is OpenStreetMap, and the second is Overture Maps Foundation. Both of them have set of features like buildings, roads, water, land use, points of interest, boundaries, and other more. And where is the data coming from? So in the case of OpenStreetMap, they rely mainly on contributors. You can OpenStreetMap, register your account, and help the community and add stuff to the maps. And Overture Maps Foundation was created in 2023 by companies like Meta, Microsoft, Amazon, TomTom, with partners like S3, and they are using OpenStreetMap data and their own internal data and structure it into a defined schema and release it monthly publicly. More details about OSM. So here you can see the Kongresowe Centrum Praha that we are currently in. This is the object on the OpenStreetMap. OSM as a data source is very popular in the community. Data is stored as nodes, ways, and relations. And the attributes of a given object are defined as tags. And you can see tags on the right, like buildings, the color of the building, height, name, and other tags. Data is updated in real time, so you can add stuff to the map and it will be available like 1 minute later. And you can get it via API and with files in a format called PBF as a big file extracts to process. And here you can, let me see. Oh, here you can see the example of a website called GeoFabric, where you can download extracts of data. So here are countries of the Europe, and you can download all of the data for a given country in this format called PBF. And the other example is Slice OSM, where you go, draw a polygon on a map, and you will download only the data for a given polygon you drew. So you can be more precise with the data you want to get. And the second source, the Overture Maps Foundation, their data is split into something called themes and types, and they have multiple definitions of different data sets. Every data set has a schema that is defined on their website. Here you can see the example of a place from dataset Meta, so it's from Facebook information. And they release data as GeoParquet files. So you don't have to do any processing like with OSM. You can just go to the public bucket on S3 and download GeoParquet data for your use cases. And I went too far. Yeah, here is the example of files on Overture Maps bucket. So just a list of files. And that's the end of the geospatial intro. Basically, there's a saying in GIS community that spatial data is not special. It's the same as data. It's just differently represented in a database. OK, so now I want to tell you what motivated me to write those two libraries. When I was doing my studies, I did some work on OSM data, doing machine learning projects at the scale of a city. Here you can see the buildings in Barcelona. And yeah, I was doing OSM and X, using OSM and X. It was fine. Data was collected like normally. I could store it on my PC. But when I wanted to get data from more cities, I had to leave the script running overnight for like 8-10 hours because it took a while to download the data from the API, transform it, and stuff like that. OK, some time went by. I wanted to scale my machine learning model to train it on the data for a whole country. So here you can see Poland, data for Poland. Unfortunately, that wasn't going to happen because I didn't have enough memory on my PC. Because OSM and X loads data into memory, and if you want to transform geospatial data, it takes a lot of memory, unfortunately. So I started looking for some other options, and the most popular ones are based on something called GDAL, like that's the main tool in a GIS community, and all the infrastructure is built on top of it. But Unfortunately, installing GDAL is not so easy. You cannot just do pip install GDAL. You have to install GDAL separately, and you have to match versions with the Python library. You can get it from Conda, but I'm not a Conda user. I use pip or UV rather currently. I've also tested another tool called Osmium. It doesn't use GDAL, and it has Python bindings, but you have to write your own logic, and without multiprocessing, you will also have to wait a long time. So in summary, getting bigger extracts of OSM data is hard at scale in Python. So I started looking for some solutions, and I found 3 requirements that would match my use case. First, I don't want to use GDAL. I don't want to use Apache Spark. I don't want to use PostGIS. I just want to run pip install and be done, basically. I want to run the code on a single machine, so I don't want to spin up a cluster on WS. I just want to use my personal PC to get data for a country or bigger. And relatively fast, so I won't have to wait whole night for something to be calculated. So quickly, a timeline of events. I started doing work in March of 2023. Then in April, the spatial extension for DuckDB was released. I don't know if you've heard about DuckDB, but it's a great new database that you can use locally for analytical purposes. 2 months later, the author of spatial extension, Max Gabrielsson, added stReadOSM function that can read data directly from the PBF file. And I started working in July and developed the code for QuackOSM and released it in December 2023. So now I can talk about those 2 libraries after this long overdue intro. QuackOSM is dedicated for getting OpenStreetMap data. Quack in the name relates to DuckDB part. It's based on a DuckDB database mainly. And OSM is abbreviation of OpenStreetMap. And the second library, OvertureMaestro, is for reading Overture Maps data, and it has similar API as QuackOSM. So here you can see the example of how you can get buildings for the city of Prague in both of those libraries. With the first library of QuackOSM, you have to use filters based on tags. So here I'm using buildings equals to true. So I'm getting all the objects from OSM with building tag in it. And with OvertureMaestro of Overture Maps, there's a dedicated theme and type for buildings. So I just download data for that. And you can see geometry filter in both of those, where you can pass a shapely object, a geometry, and it will automatically filter data only for this area of interest. And here's all the buildings that we downloaded for the Prague, zoomed into the center. So key library features of both of those libraries. First, it has a simple API and CLI. At least I hope so that it's simple, related to compared to other tools available. It saves data into GeoParquet files. Why GeoParquet? GeoParquet is a modern format in a GIS domain. It's compatible with many tools. It's also optimized for long-term storage and has fast input and output operations. Both of those libraries integrate with GeoPandas. And well, let's go next. And you can filter a query data using geometries, so you don't have to know where the data lives. You can just ask it, OK, I want data for Prague, and it will find it for you. And it should handle large regions without memory limitations on a single machine. So quick word about DuckDB. This analytical database system, the most important feature is that it can offload larger than memory operations to disk. So when there are some bigger operations, it will offload it to a temporary file and load it later. It has a spatial extension. Here you can see the example of reading some Parquet data and filtering with distance from a centroid. And it has dedicated function for reading OSM data. So here you can see st-read OSM, Praha OSM PBF, and this is the output of a single object of row in a table. If you want to learn more about reading OSM data with DuckDB, I wrote an article on Towards Data Science where you can find it and read about it. Okay. Next, something called GeoArrow. GeoArrow is a Apache Arrow extension for simple features. So it defines how points, line strings, and polygons are defined in a memory. If you don't know what Apache Arrow is, this is a memory format that is language independent, and you can move something that is in memory between different languages, between different libraries, between different tools without copying it. So it's a zero copy integration. It is compatible with GeoParquet, supported by many tools in Python, and I use it to manipulate data in the library for GeoParquet. And here you can see the example of how you can read it in Python. So there's a library called GeoArrow, and you can read a Parquet file, and this is the output with the extension format for geometry. Okay, so let's talk about some specific features of QuackOSM. It installs without any external dependencies. You can get it on pip or you can get it on Conda. And you don't have to install anything else outside of your Python environment. The main task for this library is to transform PBF file into GeoParquet, get all the geometries transformed from this proprietary format. And you can see with the CLI, I can get data for Poland in about 20 minutes. And 3 main functions in a Python module is convert PBF to Parquet if you have a file, convert geometry to Parquet if you want to find data by geometry, and convert OSM extract to Parquet if you want to find data by a string. You can also read it into geodata frame or to a DuckDB database, so the same type of functions with different output. You can run it as CLI. So it's based on typer, and you have a helper function, helper output, and also here you can get buildings for Prague with those 2 flags, geomfilter, geocode, and OSM tax filter. It automatically finds data for you. So one of the barriers, entry barriers, is that you need to know where the data is to process it in bulk, and where and what extracts are available. QuackOSM already scans 3 popular sources and has an algorithm to match the best extracts to cover a given region. So here you can see I gave it a bounding box around city of Bristol, and it found 3 extracts that will match it and discard a one that is like too big for a leftover piece of geometry. And yeah, you don't have to worry about needing to know where to get the data and to download it. It's already packaged into the library. It can filter data based on geometry, so I can get an existing big file and get only data for a small region, or I can ask it to find the data for a region, and it will automatically filter it. And you can also filter data based on tags. In the first example, I'm loading bars and cafes, so amenity equal to bar or amenity equal to cafe. In the second example, I'm looking for ice cream shops that don't have a brand tag. So, for example, looking for local ice cream shops that aren't branded, basically, with a bigger chain. And you can also use asterisks or wildcards. It will find here every object with a name in any language. So this is the asterisk after name. That has a part astronom in it. And that way I found Prague Astronomical Clock and Astronomical Tower of Clementinum that are both in Prague available. Here are available alternatives, so OSMNX and other libraries that can or cannot stream data. You can also use Apache Sedona with Spark. You can also read the OSM data with that, or you can download GeoParquet data from something called LayerCake. And OvertureMaestro. It's available also on PIP. It's not available on Conda because of some dependencies that aren't available on Conda yet. You can get data by geometry or by bounding box, and you can save it to Parquet or get it as geodata frame. Here's the example of how you can get buildings data or buildings data and roads at the same time. It will use multiprocessing to download multiple files at once, so it's faster. You can run it as CLI as well, so building, so getting buildings data for city of Prague. You can also filter data using something called PyArrow expressions. So here I'm getting water bodies with filter for rivers only and downloading only columns for names and sources. That way I can limit the data I need to get less data from the cloud. I also have something called unified combined file format because Overture has those different data sets with different schemas. I cannot combine multiple types of data into a single file. So I created a function that will take different definitions of objects. So for example, for water bodies, I get columns subtype and class to expand it to a hierarchy of objects and just pass a Boolean flag. Is this object of this type or other type? And I can do it for multiple different types. So here I have an object with an ID, geometry, and then is this object an infrastructure or a land or a place or a building or a segment of a road? Alternatives. So basically, you can use official Overture Maps library, but you can only query data by bounding box. With OvertureMaestro, you can query by a geometry polygon that is not a bounding box. And you can filter data with those PyArrow expressions. You can use DuckDB and PyArrow directly because they can query data with, from S3 bucket. And if you're using BigQuery or other lakehouse, the Overture data is already available there. OK, and at the end, I want to go back to this model I told you about at the beginning. So suppose you want to have a network of electric vehicle charging stations in your city. Basically, using open data and machine learning model, you can learn it to recognize locations with high potential. I wrote a thesis on this topic. I was using bike sharing stations, but the same principle is here. So basically, I downloaded data for Amsterdam, where the electric charging stations are. I divided city into hexagonal regions and assigned a distance from the nearest station outwards. And then I downloaded OpenStreetMap data, counted categories per each region. So like in natural language processing, you count words per sentence, for example. And you get this beautiful heat map as the end. And you can use it as a starting point in your planning process or as a nice, catchy, abstract artwork in your house. Yeah, and at the end, I want to thanks Max Gabrielson for creating the DuckDB spatial extension, Joris van den Bosse for working on PyArrow, GeoArrow, and GeoPandas, and for his tips when I met him in person on other conferences. Thank also Dewey Dunnington and Kyle Barron for working on GeoArrow specification, and to Chris Holmes and Jacob Wasserman for interactions online when talking about GeoParquet and Overture Maps. And now I want to thank you for listening. You can find me on LinkedIn, GitHub. There are the GitHub pages for the libraries. And are there any questions?
Thank you. Do we have any questions from the audience? There's one, and also you can line behind the mic over there, but I'm happy to pass it.
Thank you for the great talk. I was wondering, in your experience, which of these data sources, so OSM and Overture, provides the better, more complete data? If I was to choose one or the other, which should I choose? Thank you.
Okay, so the proper answer is it depends. Because, for example, with points of interest, you might have more structured data set because almost all the businesses are placed on Meta, on Facebook, so you get all of those. But, for example, there aren't all of the chain stores in Overture maps, but there are on OSM. So with places, it depends. With roads, you get data from TomTom or use OSM. It also depends on the region, where is it better mapped or not. But here in Europe, you should be fine with working with both of those, basically, because they are really good sources and it's well maintained. I would guess that for example, with buildings, in OSM, you only got buildings that has been traced by a person, and in Overture, you also has machine learning derived buildings. So for Africa, for example, you get data from satellite imagery. That's not the best quality, but you got it also combined with OSM. And if there is the same building in OSM and machine learning derived, then the OSM has higher hierarchy. Yeah.
Thank you. Any? Go on.
I may have missed it, but one of your motivating factors was to not have to install GDAL. I think, I could be wrong, DuckDB still requires GDAL under the hood, and things like GeoPandas and stuff require it.
To be exact, GDAL is already inside the binary of DuckDB. So technically, you are downloading it with the DuckDB, but you don't have to use it externally, and I don't use it at all inside it. Yeah.
Thank you. Any more? I can't see any. Thank you so much, Kamil. Thank you.
Thank you.